In this problem, we have to determine the rate at which the ice in a particular container melts, and we have to determine that the melting rate of the ice in a spherical container. Let us just read the question statement. A hollow spherical iron container with the outer diameter is 20 degrees centigrade and a thickness of 0.4 centimeter is filled with the iced water at 0 degrees centigrade. If the outer surface temperature is 5 degrees centigrade, determine the approximate rate of heat loss from the sphere in kilowatts and the rate at which the ice melts in the container. The heat from the fusion of water is given, that is 333.7 kilojoule per kg. Let us just try to understand this given question statement by using a graphical explanation. Consider this is the spherical container and it has a diameter of 20 centimeters and has a thickness of 0.4 centimeters. So this is the iced water which is being placed inside the spherical container, and it is maintained at the temperature of 0 degrees centigrade, and the outer surface temperature of this spherical container is maintained at 5 degrees centigrade. So we have to determine the heat loss, and secondly we have to determine the rate at which the ice melts inside this spherical container. Before going into details of the solution of this question statement, let us first of all take some assumption. The first assumption is the steady operating condition exists since the temperatures of the walls inside and outside remain constant at the specified values. So the second assumption is the heat transfer through the shell is one-dimensional. So the third is the thermal properties of the iron shell are also constant. The inner surface of the shell is maintained at the temperature same as the temperature of iced water, that is at 0 degrees centigrade. So we need some properties of the material as well as the water which is present inside the spherical container. Those properties may be given in the question statement, and or you can take those properties from the book that is being provided to you, and you can take those properties from the table A3. And the most important property that you are going to use in this problem, that is the thermal conductivity of the iron, which is not given in the question statement. The one important property that you need to solve this question statement and this problem statement, that is the thermal conductivity, and you have to take that thermal conductivity of the iron from the table A3 which is given in your book, and this thermal conductivity of the iron is 80.2 watt per meter per degree centigrade, and the heat of fusion of water which is given in the question statement, that is 333.7 kilojoule per kg. The first and foremost thing that you have to perform is to determine the area of this spherical container. So the area of this spherical container can be determined by using this formula, that is pi d square, and the diameter of this spherical container is given in centimeter units, that was given in the question statement. When you convert it into the meters, that will be equal to 0.2 meters. When you put all the values in this formula, you will get the area of this spherical container, which will be equal to 0.126 meter square. The rate of heat transfer through the shell is mainly due to the conduction, and we have to use this formula, and in this formula that we have to determine the rate of heat transfer, and we have to put all the values that we have so far. We have the thermal conductivity of the iron, we have the surface area, we have the temperature difference, and we have the thickness of the wall of the spherical container. And after putting all the values such as thermal conductivity and the area that we have calculated in the previous slide, the temperature difference and the thickness of the wall of the spherical container, and after simplifying that, we will have the value of the rate of heat transfer, that is 12,632 watt. And it was given in the question statement that you have to get the value in the kilowatt. So what you will do is you will divide this by 1000. You will get 12.632 kilowatt. So the next is we have to determine the rate at which the ice melts inside the container. So we are given with the heat of fusion in the question statement, that was 333.7 kilojoule per kg, which means that it takes 333.7 kilojoule of energy to melt 1 kg of ice at 0 degree centigrade. So we have the formula, that is the rate of heat transfer is equal to the rate at which the ice melts into the water inside the container multiplied by the heat of fusion. So if we rearrange this equation, or we will get this equation, and we have this the rate of heat transfer that we have determined in the previous slide, and the heat of fusion is given in the question statement, and we can put the values in this formula, and after simplifying that, we will get the rate of ice melting inside the container. So the final answer is 0.038 kilogram per second.